say something. I have my fridge here. Let's say my fridge has a temperature of 4 degrees Celsius. How long would it take for this 85 degrees Celsius coffee mug to reach 15 degrees Celsius inside my fridge? Well, it turns out we can find it by just using some physics, thermodynamics, and math. Let's figure out how. So here I have our setup here where our fridge is 4 degrees Celsius. At 85 degrees Celsius is 0 minutes, so this is the initial temperature. And at 65 degrees Celsius, it is at 5 minutes. And we have to use this equation known as Newton's law of cooling, which states that the rate of which an object loses or gains heat is directly proportional to the difference in temperature between the object and its surrounding environment. What we're trying to achieve and get out of this equation here is a function t of t, where we can find the temperature in relation to time or the time in relation to temperature. So first, we have to separate the variables by time using dt to both sides. So big T equals negative k times t minus to times d little t. So now we're gonna divide t minus to on both sides. We're gonna get this equation. dt over t minus to equals negative k times dt. Now to separate t, we have to integrate both sides. And this side is pretty much saying 1 over t minus to, and we're differentiating with respect to temperature. So let's integrate both sides here. Here we have a 1 over something problem, which means we can use u sub. So let u equals t minus to. If we do u sub, we'll get 1 over u du, which is just going to equal natural log of absolute u, and we can just sub back in t minus to. So this side is going to integrate to natural log of absolute t minus to. This side is really simple to integrate. We're just going to apply a variable to that because that's a constant, and then we're just going to plus c. We still need to isolate our variable t, so we're just going to put e to both sides. Since this has a natural log, the e and the natural log will cancel out, which will give us t minus to equals e to the negative kt plus c. Now we can separate the variables to get t minus to equals e to the negative kt plus e to the c. Now we can separate the variables as e to the negative kt times e to the c, and e to the c is just going to be some constant. So we're going to get t minus to equals e to the negative kt times just some constant c. And we're just going to finally add to to both sides. So we're going to get an equation t of t, so temperature of time, equals to plus c times e to the kt. Let's actually start identifying some variables here. T of t is just the temperature of the coffee at time t, and to is just the ambient temperature or the fridge temperature. C is just some constant. E is just Euler's number, and k is the cooling constant, and t is the time. So let's plug in our initial conditions. T of t is 85, and to is 4 plus some constant c to the e, and then negative k, and our t is going to be 5 because it's 0 minutes, so our time is 0. And since this is multiplying by 0, that's just going to be 0. So times that, e times to the power of 0 is just going to be 1. So we can rewrite this as 85 equals 4 plus c. And to get c alone, we can just minus 4 on both sides. So we get 81 equals our constant c. We can rewrite the function as 65 equals 4 plus 81e, and e is just Euler's number here, which is just, and negative k, we still don't know, and t is going to be 5 minutes. To solve for k, we're just going to minus 4 on both sides, so we just get 61 equals 81e to the negative k times 5. We're just going to divide 81 on both sides. So you get 61 over 81 equals e to the negative k times 5. And to get rid of this e here, we're just going to have to apply a natural log to both sides. So natural log of 61 over 81 is going to be negative 0.2835 equals negative 5k. So now we're just going to divide negative 5 on both sides. We get our cooling constant as 0.056715. And that's k. Now we can write a new function. T of t equals 4 plus 81e to the negative 0.0567t. And now we just need to find little t here. Because we know t of t, what we're trying to find is 15 degrees. So we can just plug that in. T is what we're trying to find. So we're just going to minus 4 on both sides. We're going to get 11 equals 81e to the negative 0.0567t. So we're just going to divide 81 on both sides. We have 11 over 81 equals e to the negative 0.0567t. Now what we're going to do is just natural log both sides to get rid of E here. And we're gonna get our final answer as 35.2 minutes. To verify our answer here, we can actually grab this function and find the time. So here we have our function t of t equals 4 plus 81e to the negative 0.0567t. And to find the time at 15 degrees Celsius, we can just write a new function t of t equals 15 and find the intersection, which is, as predicted, 35.2 minutes. Here we have our 85 degrees Celsius coffee in a fridge that is 4 degrees Celsius, and we have to run this to 35.2 minutes to see if the temperature T of T is 15 degrees Celsius. So let's just play this. And if we scrub forward to 35.2 minutes, we can see that the temperature is 15 degrees Celsius exactly as we predicted. And yeah, that's the video. Thank you for watching.